Today we will be discussing about GZ curve or curve of statical stability. So let's move on to topic. GZ curve or curve of statical stability. It is the most common graphical representation of ship's transverse statical stability. Here the graph represents righting lever, that is GZ, against angle of heel. This is the most common graphical representation for ship transverse statical stability. Here it will represent righting lever against angle of heel. So this curve plotter for every voyage, and it is for a particular kg and displacement. Okay. So in this graph we can see there will be initial metacentric GM metacentric height, then there will be after some period of time there will be angle of contraflexure, then there will be maximum GZ, then 57.3 degree there will be angle of vanishing stability will be there, then negative shall be there. This is the graph that represents it. From this curve we can understand it is possible to get the GZ value for any angle of heel, and this can be used to find moment of static stability at any angle of heel. This is from this curve we can find out GZ value for any angle of heel, and this can be used to find moment of static stability at any given angle of heel. And for a moment of writing moment calculation, for example t minus f, from the graph we can find out GZ into displacement of ship will be writing moment. So initial metacentric height GM, it can be found by drawing a tangent to curve through origin, then erecting a perpendicular through angle of heel from 57.3 degree. The two lines are allowed to intersect. The value of GZ is noted, which is initial GM. Here from this figure we can say it can be found by drawing a curve through origin from then erecting a perpendicular through angle of heel 57.3 degree. Then the two lines are allowed to intersect. The value of GZ is noted, which is initial GA. Then angle of contraflexure, angle of heel up to which rate of increase of GZ with heel is increasing. Though GZ may increase further, the rate of increase of GZ begin to decrease at this angle. Angle of contraflexure means here the angle of heel up to which rate of increase of GZ with heel is increasing. So GZ may increase further, but rate of increase of GZ begins to decrease at a certain angle. This is known as at angle of contraflexure. Here we can see angle of contraflexure. Here means angle of heel up to here will be high because the rate of increase of GZ with heel is also increasing. Though the GZ may increase further, but after some time the rate of increase of GZ begin to decrease. So the angle will also get decrease. Then range of stability. Range of stability means where all GZ value are positive and maximum GZ lever and angle at which it will occur. And angle of vanishing stability, beyond which this angle of vanishing stability the vessel will capsize. That means the area of negative stability, minus axis we can from the graph. Then moment of dynamical stability means work done in heeling ship to a particular angle. To a particular angle, the heeling can be work done in heeling. That is known as moment of dynamical stability. Then cross curves will be there. Cross curve means there are two or more curves, that is cross curve. These are given by shipyard under stability book. In the shipyard it can be seen in the stability book because more than one or more than two curves will be there. Here GZ cross curve for stability. To draw a curve of static stability, we need GZ value for various angle of heel. For this we use GZ cross curves for stability. To draw a static stability, we need to find GZ value of various angle of heel. To find this GZ value, we need to use GZ cross survey of stability, cross curve of stability. The graph where righting lever GZ is plotted against the displacement. Here we can see GZ righting lever. These curves are plotted from kg and tabulating GZ value for various displacement and against angle of least. So these curves are plotted for assumed kg and tabulating GZ. That is GZ means righting lever for various displacement and angle of east. It is called a cross curve because of various curves cross each other. So these curves are plotted for an assumed kg. So actual kg difference from this and a correction, that is g1 sin theta, should be applied. And this correction is positive. If actual kg is less, then it should be applied. Then and vice versa. So after obtaining the GZ values at various angles, the curve of static stability will be seen like this. We can prepare. So like I mentioned, to draw the curve of static stability, we need to have gz value at various angle of field. For finding the gz value, it can be find from the gz curve of stability, and graph where right lever is plotted against displacement. Here we can see gz will be plotted against displacement in this graph, and various curves are plotted for assumed kg, and tabulating gz values for displacement and angle of list are also seen from this figure. And it is also a cross curve because various curves are crosses each other, and curves are plotted for assumed kg and all, so that actual kg difference from this correction, that is g1 sin theta should be applied, and correction is positive if actual kg is less than assumed kg, and vice versa. Then if correction is negative, means actual kgs will be more than assumed kg. Then after obtaining gz value at various angle, curves of static stability will be prepared. Then Kn cross curve of stability. It is almost similar to that of gz cross curve, and also used to get gz value for making the curve of static stability. Kn curves can also be used to find the gz cross value for gz value for making curve of static stability. The only difference being that here kg is assumed to be 0, and Kn being the right hand lever measured from keel. Here kg will be, we will consider kg to be 0, and Kn being the right hand lever measured from the keel. This solves the problem of sometimes positive and sometimes negative correction. As of now, correction is always subtracted. We all know that correction will be subtracted. Gz is equal to Kn minus kg sin theta. Like this, we can have sometimes the correction will be positive, sometimes will be negative, but correction is always, we know that formula Gz equal to Kn minus kg sin theta. This can be the graph of Kn cross curve of stability. So this is what we have discussed about gz curve and curve of static stability.